Let's look at our first question here. Here we were actually given what? From our first question, we have that 1 kilogram of CO2 gas in a container of what? 2 meter cube under heat interaction until the final pressure becomes 3 times initial pressure. If the initial temperature and pressure are 35 degrees Celsius and 1 atm respectively, determine the final pressure and temperature, work done, quantity of heat enjoyed by the system. Now looking at the question given, we're actually given to find three things. The first thing is to find the what? The final pressure and temperature. Now the next thing which you are given was to find the work done by the what? System. Now I told you that when you have to calculate for work done here, there are three things you need to consider. The first thing is what we call the workflow of the system, the workflow of the system. Another thing is the non-flow work of the system, the non-flow work of the system. And the last thing is called the shaft work. The shaft what? The shaft work, right? Now, if you've been able to calculate for these three parameters, then you've calculated for the work done by the what? System. Now, let's look at the next question. The next question talks about the quantity of heat enjoyed by the gas. The quantity of heat enjoyed by the gas. Now, what do? We cannot just calculate for the quantity of heat just like that. If we are considering the quantity of heat, then we are going to consider the heat for state 1 and state 2, which is what? Q12. You are going to consider Q12. You are also going to consider change in what? Internal energy. You are also going to consider what? Change in what? Enthalpy. And also you are going to consider what? Change in what? Entropy of the system. So if you can calculate for these four parameters, then you've what? You've been able to calculate for the heat enjoyed by the what? Gas. Now remember, the gas that was given to us was what? CO2. So note, the gas that you were given in the question was what? CO2. Now let's go into getting the known parameters and using our known parameters to find the unknown parameters. Are we together? Now the first thing you do is you bring out your given data. So let me change the pen. Let's say we have a black pen and you want to use to simplify. Now our data. So the first thing you do is you bring out your given data from the question you have. And they said 1 kilogram of CO2 gas. So the first thing you have there is what? Mass. So we are given mass to be what? 1 kilogram, right? Now from the question, we're also given that the gas is CO2. So you note the gas is CO2 in a container of 2 meter cube. What is 2 meter cube telling you? You are given what? A volume. Now remember, the volume you were given here was just one volume, which is what? 2 meter cube. What next are you given? Then you were asked that the container of what? 2 meter cube under heat interaction until the final pressure becomes 3 times its initial pressure. So it's a condition that is given to you. So we are actually given for your final pressure, which is what? P2. So we have P2 here, and they said for you to find P2, P2 is what? 3 times the initial pressure, which is what? P1. Are we together? So it's left for you to know what is P1, and you multiply 3 with P1 to get your what? P2. Are we together? Now the next thing you have there from our question, we were given that the initial temperature and pressure are what? 35 degrees Celsius and what? 1 atm. Are we together? Now what you simply do is you come down and write your what? T1, and we are given T1. What's T1? They say T1 is what? 35 what? Degrees Celsius. Now in this course, we don't use Celsius. What we use is what? Kelvin. So we convert degrees Celsius to what? Kelvin. How do you do that? By adding what? 273 to your degrees Celsius. So what we do here is to add this with what? 273. And if you add 273 to 35 degrees Celsius, you are simply going to arrive at what? 300 and what? 8 Kelvin. So this is your new temperature, right? And this is your what? Your T1. What's T2? T2 was not given, right? So T2 was not given, P1 was given, and P1 was given to be what? 1 atm, right? Now, what is 1 atm? What you do is to convert 1 atm to either Pascal or what? Kilopascal. ATM simply stands for atmospheric what? Pressure. Atmospheric pressure. And one atmospheric pressure is equivalent to what? 100. One atmospheric pressure is equivalent to what? 101 point what? 325 kilopascal. So instead of using 1 atm, we'll be using what? Kilopascal. Are we together? Now we've succeeded in getting P1, P2. We've succeeded in getting P1 and T1, but we don't know what's P2. But here we're given a condition that P2 is what? 3 times P1. So if we have P1 to be 101.325, what will be P2? P2 will now be equal to what? 3 times what? 101.325, right? And what will this give us? If we multiply 3 with 101.325, you will simply arrive at what? 303. This will give you 303 point what? 975. And what will be your value? It will be in what? Kilopascal. Always add your value to your given parameters. It's very necessary. Now remember, from the question also, from this question, we're also given that the Cp is equal to 1.006 per kilojoules per kilogram multiplied by what? Kelvin. So we are given pressure constant and we are also given what? Volume constant. Now you can still put them down. You can still put them down in your data. You can still put the 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 pressure we are given. So we are giving pressure constant to be equal to what? 1.006 kg per what? Kilogram multiplied by what? Kelvin. And we are also giving volume constant to be what? 0.718 kilojoules per what? Kilogram multiplied by what? Kelvin. So these are constant values that will be given to you in your question. Are we together? So we've succeeded in getting P1, P2, and T1, right? Now your interest is to get what is T2. Now remember, before we calculate for T2, we first need to consider what process is this. Remember, we talked about different processes in thermodynamics, right? And we said for each of these processes, they have their unique what? Parameters. When I mean unique parameters, they have parameters that are always constant for each of these process. Now, looking at this process, we can see that we are considering a rigid what? A rigid system. Now, the rigid system we are considering here is just having what? One volume, and that volume is the constant volume in this question. So since we have the volume to be constant, which is what? 2 meter cube, this process is now called your isochoric process. Why is it called isochoric process? It is called isochoric process because what? Volume is what? Constant. So you can come down to your given data and tell your examiner that the process we have here is called what? Your isochoric what? Process. Are we together? Now, since you've gotten to know the type of process, what will be the equation of state for this process? That was why I gave you the simplified table. Now what you do is each and every process have their own unique equation, which we already proved, right? So since we've proven that equation, we'll simply get to know the equation of state for that process. Now look up. The equation of state for isochoric process was what? P1, T1, P2, T2. This is for state 1 and this is for what? State 2. So what you do is you go back to your question, you go back to your given data and tell the examiner that the equation of state from the equation of state we had that what P1 divided by T1, and this is equal to what P2 divided by what T2. Are we together? Now remember, your interest is to get what is T2, what is your final temperature. So what you do here is to make what T2 subject of the formula. So what you do is you cross multiply. If you cross multiply, you simply have T2 multiplied by what P1, and this will be equal to what P2 multiplied by what T1. Are we together? So your interest is to know what is T2. You divide both sides by what P1. We divide here by what P1, such that we have our T2 to stand alone to be T2 will now be equal to what P2 multiplied by what T1, and this is dividing what P1. Are we together? So what you simply do is you impute your given values in this new equation to get what is what T2. Are we together? Now let's go to a new page. So we're actually given that our T2 will be equal to what? T2 will be equal to P2 T1. So we have P2 multiplied by T1 divided by what? P1. So what you do is you impute the values. Imputing the values, we know what is P2, we know what is T1, and we also know what is what? P1. Now, what is P2? P2 is simply 303.975. So you have 303 point what 975 divided by what is P1? P1 is 101 point what 325. Now remember, we have T1 here, and your T1 will be multiplied with what? What was your T1? Your T1 was what? 308 Kelvin. So you have this to be multiplied with what? 308 Kelvin. So what you do is you punch your calculator to get to know the value of what? T2. Now punching my calculator, I arrive at the value 924 Kelvin. So this is the new temperature that we have for what? T2. Are we together? Now go back to your question. Go back to your question. What were you asked to find? We were asked to find our final pressure and temperature. Final pressure, which is what? P2, and final what? Temperature, which is what? T2. Are we together? So we've actually gotten these two values. We already know that our P1, our P2 was what? Our P2 was 303.975, while our T2 was what? 3 our T2 was what? 924 Kelvin. Right. Now let's go back to the next question. The next question says work done. Work done. Now I told you that before you calculate for work done, you need to know what is the workflow, the non-flow work, and the what? Shaft work. Now go back to our simplified table. I gave you this simplified table so that you will know the equation to use for each of these parameters. Now for your workflow, what is the equation for workflow? We have change in what? PV. Change in what? PV. This table will help you to simplify each and every parameter when you are given for your work done and for what? The heat interaction of the system. So what you do is you go back to your simplified table, you pick the equation that is for each parameter, and you impute your values and you get that parameter of interest. Are we together? Now the parameter of interest now is for what? Workflow. For isochloric process, now this is your isochloric process. You are picking the equation for what? Workflow, which is what? Change in what? PV. So you simply have your new equation here to be what? For your workflow, you simply have the equation change in what? PV, right? But remember, in your question, we were given what? Mass, and our mass was what? 1 kilogram. So if you are given any mass in your equation, you should know that your mass will be multiplied automatically with the given equation for each parameter. What do I mean? For your workflow now, since you are given mass, what happens is your mass will be multiplied with this equation, having this equation to be what? Mass multiplied by what? Change in what? PV. Are we together? So what you simply have here will simply be what? M multiplied by V, and this will be what? P2 minus what? P1, because what we have here is change in what? PV. V is a constant value, P is not constant. Since P is not constant, we are considering state 1 and what? State 2. So what you simply do is use your state 2 to multiply with your what? Your state 1. Are we together? Now what's the value? What are the values of these parameters? You impute the values of these parameters into the given formula to get your what? Your workflow. Are we together? Now what's the given parameters here? The first one we have here is what? Mass, right? So we are given mass to be what? 1. So we have 1 multiplied by volume was what? 2 meter cube. Volume was 2 meter cube. Now what's our pressure? We have our final pressure to be what? Our final pressure to be 303.975. So we have here to be what? 303.975 minus P1. P1 is what? 101.325. So what you simply do is you punch your calculator to get the workflow. Now after imputing my values, I punch my calculator and I arrived at what? 405.3 kilojoules. Are we together? So this is the value for your workflow. This is the what? The value for your what? Workflow. Are we together? Now the next thing is to get to know what is your non-flow work. Non-flow work. Now to consider your non-flow work, you go back to your given table. For your non-flow work, what we have here is 0. So for this system, we don't have any what? Non-flow work. So meaning if you are given an isochloric process and you have to calculate for the work done of that system, work done on the system, you need to consider the workflow, the non-flow work, and the shaft work. But when you are considering isochloric process, you should have it in mind that that process will be what? The non-flow work of that process will be equal to what? 0. That's why we have 0 here. So this 0 is just telling you that, okay, this process will not have what? A non-flow work. So since this process will not have a non-flow work, our new equation for WNF, which is representing our non-flow work, so your non-flow work will be equal to what? 0. Now what's the next thing you have to do? You have to calculate for the shaft work. You have to calculate for the shaft work. Shaft work. We have to calculate for the shaft work. Now looking at the question, if you look at the system and we are to consider the system in terms, if you are to consider shaft work in terms of the system, remember the system here is a rigid system. Is a rigid system. Rigid system in the sense that it's not having any rotating part. Now, when we are considering shaft work, we are considering a system that is having what? A rotating part, such as the turbines, such as a system that is composed of what? Pump, such as systems that is composed of any rotating part. Rotating part. So when we are considering shaft, we are considering what? Rotation. Are we together? Now from our given system, we are just told that the system was what? Under heat interaction. And heat interaction, the system was in a container also. So the first thing you are taking is what? The system was in a container and the system undergo what? Heat interaction. So we are not mentioned, they were not in the question, it was not mentioned that the system had a rotating part. So since the system is not having any rotating part, we assume or we are taking that the system will not have what? A shaft work, because there was no what? Rotating part. For your shaft work, this will be what? 0, due to the fact that the system is a rigid is a rigid system. So we are considering shaft work due to the system. Since the system is not having any rotating part, we are taking that the system will be equal to what? 0. Now let's go back to our given simplified table. Looking at our simplified table, we are given an equation for what? Shaft work. What's the equation? We're given that the equation will have what? Minus V into what? P2 minus P1, and we're also given that we have another equation minus R multiplied by what? T2 minus T1. Now, if you are given a value for your shaft work in your question, if you are given a value, what you simply do is you recall these two equations, because any value you be given for your shaft work will have a negative value. It will have what? A negative value due to your what? Your formula for shaft work. But if you are not given any value for your shaft work for a particular system, and you know that that system is a rigid system, you are taking the shaft work to be 0. But if we were to follow the simplified table, we are to get the certain value for shaft work, and it will be a what? A negative value. Now let's look up. If you have the shaft work formula to be minus V into P2 minus P1, we can see that this formula is the same formula with our what? Work flow. But the only difference is the negative sign we have here. So if you want to use this formula to calculate for your shaft work, you will simply have that for your shaft work, we have minus what? V into P2 minus what? P1. So if you want to use this formula, remember you are going to multiply what? Mass to this formula. Therefore, you'll be having this to be what? Minus what? Mv divided by P2 minus what? P1. Now we know the value for mass, right? And we have that our mass is 1 multiplied by volume is what? 2 into 303.925 minus what? 101.325. Now this was the same parameters, this was the same values we have for our workflow. So if you do that, you simply have that this will be what? Minus 405 point what was the value for your workflow? 405.3 kilojoules. So you have your shaft work here to be minus 405.3 kilojoule. This will be the value for your shaft work. Now remember, from our question, we were given that the gas is a what? It was what? CO2 gas. We are given that your gas was what? CO2. So what is this telling you? We are to use the value for what? The general gas constant for what? CO2, not just the general gas constant we know to be what? 8.314. So what you do is you get the gas constant for CO2. Now how do you calculate for the gas constant for CO2? Remember, gas constant is given to be what? R of CO2 will be gotten with the equation Ru, which is the general gas constant, divided by the molar mass of what? CO2. Are we together? So first thing first is to get the molar mass for your gas given. So we are to calculate for the molar mass of what? CO2. Now, how do you calculate for the molar mass of CO2? You get to know the value for carbon, and you also get to know the value for what? Oxygen. Now, for carbon, carbon is what? 12, right? So since carbon is 12, oxygen is what? 16. But remember, oxygen is having what? A subscript of what? 2. So this will be plus 16 times what? 2. Are we together? Now, if you do that, 16 times 2 is what? 32, right? So if this is 32, you simply have 12 plus what? 32, and this will give you what? 44 gram per what? Mole. So this is the molar mass for CO2. So what you simply do is you impute this formula, you impute this molar mass into our given formula, which is R for what? CO2 will now be equal to, remember, Ru is your general gas constant, and your general gas constant still remains the constant value of what? 8.314. divided by what? Your molar mass for CO2, which is what? 44 gram per mole. And if you do your calculation with your calculator, you simply have the value for your general, your gas constant for CO2 to be what? 0.18895. And what will be the value? Kilojoules per what? Kilogram per what? Kelvin. So this is the value for your gas constant for CO2. Let's consider the heat enjoined by the system. The heat enjoined by the system. So let's consider the heat enjoyed by the system. In essence, we are to consider the what? The heat interaction of the what? System. Now I told you that when you want to calculate for the heat interaction of the system, the first thing you get to calculate for is what? The heat for what? State 1 and state 2. So what you simply do is you go back to your simplified table, you get the equation for the heat for state 1 and state 2. Now from our table for isochoric process, we have that for state 1 and state 2, if you want to calculate for the heat, you simply have the formula CV change in what? T. This is the formula we have to consider. So here we have our formula to be what? CV change in what? T. What's this telling you? This is what? Volume constant multiplied by the what? Change in what? Temperatures. Now what you have here, since you have mass, your new equation will be mCV into T2 minus what? T1. Are we together? But if you are not having mass, then you simply use your equation, which is what? CV change in what? T. Are we together? Now imputing the values, we'll simply have that mass was given to be 1. What are we given to be our volume constant? So from our question, we were given that our volume constant was what? 0.715. So we have our volume constant here to be what? 0. What? 7 0 point what? 715. Is it 0.715? We are given 0.718, right? And what's the unit? The unit is what? Kilojoules, right? So we have kilojoules per kilogram multiplied by what? Multiplied by Kelvin. And this will be into what? What's T2? We have this to be 924 Kelvin minus what's the next one? 308 Kelvin. So what you do is you punch your calculator and you get the unique value for your Q12. Now punching our calculator, we arrive at Q12 to be equal to what? 44. Q12 is equal to 4,402. For So we have our Q2 to be 442.3 kilojoules. You know why it's kilojoules, right? Because what you have here will be what? Kilo will be Kelvin. Kelvin will be left here. So since Kelvin will be left here, Kelvin will cover out this Kelvin here, and you're left with what? Kilojoules, right? Now this kilogram will be removed by the kilogram of the mass here, and you're now left with what? Kilojoules. That's why we have the unit for your Q12 to be 442 point what? So we have the value here to be what? 442.3 kilojoules. Now the next thing we have to calculate for is what? Change in internal what? Energy, which is delta U. Now from our simplified table, you need to know the value for your delta U. What equation are you to use for your delta U? Now looking at this, we have the same equation with our what? Q12. So what you do is you simply put it in this way. Since you have the same equation, you simply have that your change in U will be equal to what? Q12. So this is telling the examiner that since you have the same equation with change in state 1 and state 2, you have the same value with what? the heat interaction equation, which is what 400 and what 42.3 kilojoules. Now let's go back to the next one, which is what change in what enthalpy. Change in enthalpy. Now let's go back to our simplified table to get to know the equation for change in enthalpy of the system. So we are to use the equation Cp change in what T. So we are using what pressure constant multiplied with what change in what temperature. So that will give us Cp multiplied by what change in what temperature. Now we are giving our Cp to be what? Remember, you are giving mass. So since you are giving mass, you have this to be m multiplied by Cp, and this will be multiplying what T2 minus what T1. Now if you impute the values here, you simply have this to be what 1 kilogram, right? So always impute your values to know your final what parameter that you have there as your unit. And what's Cp? Cp was given to be 1.006 kilojoules per what kilogram per Kelvin, and this will be multiplying what T2, which is 924 Kelvin minus 308 Kelvin. So what do you think your value will be? Now punch your calculator and drop your value on the comment section. So I will use it to confirm my own value. Now from my own value, I got what 619.70 kilowatt joules. Why is it kilojoules? Your Kelvin will, if this is multiplying each other, you have a certain value, and you just have one unique value for what Kelvin, and this value will be subtracted with this value, will be washed out with that value. You are left with kilogram here. This is kilogram. This is kilojoules divided by what kilogram. So this is removing your kilogram, and you're left with what kilojoules. That's why we have the unit to be in what kilojoules. So you have your change in enthalpy, which is change in H, to be what 619.70 what kilojoules. Now let's go over to the last one, which is what change in what enthalpy. Change in entropy. Now, to calculate for the change in entropy, we have that your change in entropy is given with the unique equation Cv ln T2 divided by what? T1. So what you simply do is you go back to your given question. You have that your change in what? Your change in entropy is what? Cv ln T2 divided by what? T1. We are given mass, so you have this to be mCv ln what? T2 divided by T1. So imputing the values, we already know our mass to be what? 1 kilogram multiplied by your Cv. What's your volume constant? We have our volume constant to be 0.718 ln 924 divided by what? 308. So what you do is you punch your calculator and you get a certain value for what? Change in entropy. And what's the value? The value I got from my calculator was what? 0.789 kilojoules per Kelvin. And this is the unit for entropy. So we've succeeded in getting the work done of the system and also the heat enjoyed by the system. For this particular question, the question simply says what? 1 kilogram of air entrapped in a frictionless piston cylinder with its arrangement undergoing isothermal what? Expansion. Isothermal. So you should underline the word isothermal what? Expansion at what? 85 degrees Celsius until the pressure decreases from 1.5 atm to what? 1 atm. So they are giving you your initial pressure and your final what? Pressure. What's your initial? Your initial was what? From 1.5, and your final is what? 1 atm, right? So you are saying atm, what should come to your mind? Kilopascal or what? Pascal. If the initial pressure is if the initial pressure is 0.5 meter cube. So what we are giving here is volume, not pressure. This is supposed to be what? Volume. So take note. This is what? Volume. If the initial volume is 0.5 meter cube. So you are given your initial volume, and here you're now asked to find what? Determine your final volume, which is V2. And here you also asked work done, and I told you for your work done, you are to calculate for your workflow, right? Your workflow, your non-flow work, and the last thing is to calculate for your shaft work when we are considering for work done. Now the next thing we are seeing there is the what? Your heat interaction. And I told you that when you want to calculate for your heat interaction, you have in mind that you are going to calculate four parameters: your Q12, the heat for state 1 and state 2, your change in what? Internal energy, change in what? Enthalpy, and what? Change in what? Entropy. Are we together? So if you've gotten these four parameters, then you've calculated for the heat interaction by the what? System. Are we together? Now the first thing that should come to your mind is, from what we have here, what process do you think we have here? The process we have here, we are seeing that 85 degrees Celsius is only the constant temperature that we have in our question. And we also mentioned isothermal what? Expansion. So what process do you think this question is actually talking about? We have what? Our what? Isothermal what? Process. Isothermal process, where what? Temperature is constant. Now let's bring out our given parameters, and we'll use our given parameters to find those parameters that are not given, which are the what? The volume, the work done, and the what? Heat interaction. Now from what we are given a mass, and we are given a mass of what? 1 kilogram, right? So our question, we are given a mass, and our mass was what? 1 kilogram. But remember, it was what? Air. We were given the mass, they said 1 kilogram of air entrapped in a frictionless piston cylinder. So what we are considering is what? We are considering air. Are we together? Now what should come to your mind is, if we are to consider air, what will be the gas constant for air? Are we together? Now remember that what we have here, we are to consider air. The question is considering air, right? So since we are considering air, what's the arrow air? What's the arrow subscript air of this question? What's arrow subscript air? It simply means what's the gas constant of air in our question. And we know that from our previous calculation, for us to calculate the R of air, we'll simply use the general gas constant divided by the molar mass of what? Air. So basically in your question, some questions, they will give you the molar mass of air in that question. And we know that the molar mass of air is what? 28.97. And we also know that RU is a constant value, which is what? 8.314 divided by what? 28.94. Your 28.94 will always be given to you in your question if you have air, oil, and other what? Parameters, as the case might be. But in this question, we're given that 1 kilogram of air was entrapped in a what? A cylindrical, frictionless cylindrical what? Piston. Are we together? Now, with further ado, if you punch your calculator 8.314 divided by 28.94, you simply have a new value to be what? 0.287 kilojoules per what? Kilogram multiplied by what? Kelvin. So this is the value for your gas constant of what? Air. What's the next thing? The next thing is, from our question, we are given P1 to be our initial pressure, and we are given P1 to be what? 1.5 atm. So it's left for you to convert 1.5 atm to kilopascal, and you simply have what? 151.988 kilopascal. What's the next thing we are given? From our question, we are also given that our P2 was what? 1 atm. So we have our P2 here to be what? 1 atm, and it's equivalent to what? 101.325 kilopascal. What are we giving? We're also giving the initial volume, which is V1. The initial volume, and we said the initial volume from the question is given to be what? 0.5 meter cube. So we have our initial volume, which is what? 0.5 meter cube. Are we together? Now remember, we said that what process is our question actually referring to? We said the process was what? Isothermal process. So you always tell your examiner the type of process that your question is actually talking about, right? Now the next thing is for us to know what is what? V2. Are we together? It's for us to know what is V2. But remember, if you've already known the process that your question is talking about, what you do is you get the equation of state for that process and use the equation of state to simplify to get your parameter that is not given, which is what? V2. Now recall that the equation of state for your isothermal process from the table I gave you, from our simplified table, if we are going to isothermal process, we have that what? P1 V1 is equal to what? P2 V2. I think this is Boyle's law. Boyle's law. This is Boyle's law. So if we are to use the Boyle's law equation, we'll simply have P1 V1 is equal to what? P2 V2, telling us that we have state 1 and what? State 2. Now remember, our interest is to know what V2 is. Now that is telling us to make V2 here subject of the formula by dividing both sides by what? P2. So if you do that, we simply have our V2 will be equal to what? P1 V1 divided by what? P2. So this is the equation we are to use to get the final volume of the system. So if we use that equation, we'll simply have that our V2 will be equal to what was the parameter given? We have P1 V1 divided by P2. So we have P1 V1 divided by what? P2. Now let's impute the values here. What's the value for P1? We had that the value for P1 was what? 151.988. So here we have 151.988 multiplied by V1. What's V1? From our question, we have that our V1 is what? 0.5. So here we have this to be what? 0.5 divided by what's P2? P2, we have P2 to be 1 ATM, and we had 1 ATM to be 101.325. P2 is what? 1 ATM, and 1 ATM is equivalent to what? 101.325. So we are going to impute what we have here to be P2 to be 101.325. Now what do? You simply punch your calculator to get the value for what? We simply punch our calculator to get the value for V2, and it will be what? In meter cube. So what you simply have is what? 0.73 meter cube. Are we together? Now please always confirm the value and drop the correct values on the comment section. Are we together? Now since we've gotten to know what are our parameter, and from our given question we've actually calculated for the first question, which is what? Final what? Volume, and our final volume is what? 0.73, I think 0.73 or 75. So you drop the correct answer on the comment section. So we are taking 0.75. That's what I have from my calculator. Now what's the next thing we have to calculate for? Is our what? Work done. And I said for you to calculate for your work done, you need to calculate for the workflow, the non-flow work, and the what? The shaft work. Are we together? Now let's go back to our given table for us to know what our workflow will be. Now for you to calculate for your workflow, come to your table. What's the equation for workflow? Now from our table we have that for workflow of isothermal process, the workflow of isothermal process is actually what? 0. So you go back to your question, you tell your examiner that the workflow for this process will be equal to what? 0. There's no need for you to stress yourself in calculating. That was why I made this simplified table. So you go back to your simplified table, you get the equation that you need to know, you come back, you impute the equation, you impute the equation, you impute the values, and you get your answer. Now the next thing is to calculate for your non-flow work. Non-flow work. Now from the table, what's non-flow work? From your table, we simply have our non-flow work to have an equation for our isothermal process, which is this. You have this to be your RT V2 divided by what? V1. So what you are going to do is you are going to take the general gas constant of air multiplied by the temperature, and this will be ln. This is ln, so take note. This is ln V2 over V1, or better still, you can take what? RT ln what? P1 over what? P2. So if you use each of this formula, you still get the same what? Value. Now let's go back to the non-flow work and make some calculations and see if we have the same value if we use the different formula that was given to us in our table. Now from the formula that was given to us, we were given that our non-flow work from that formula will be what? We will have our non-flow work to be equal to what? RT multiplied by what? Ln V2 over what? V1. So you impute your ln in your table. Try and impute it. Now, with further ado, what is now the R here? Remember, we are given mass. Since we are given mass, you simply have your non-flow work equation to be mRT ln V2 over what? V1. Are we together? So what do? You impute your value. So you have your mass to be 1, right? Multiplied by, what's your R? What's your R? Remember, the R that you calculated was what? 0.287. So you had your R to be 0.287. That was what we calculated. And let's confirm that value, 0.287, which is our what? R for air. General gas constant for what? Air. So since we've gotten the value for our general gas constant for air, what was the temperature given? Now remember, the temperature, you were given temperature to be in what? 85 degrees Celsius. So take down. So since you are giving temperature to be in 85 degrees Celsius, you convert your 85 degrees Celsius to what? To Kelvin by adding with what? 273. And if you punch that with your calculator, you have your new temperature to be what? 358 Kelvin. Are we together? So since we've gotten 358 Kelvin, you go back to your equation and you impute your new value for your temperature, which is what? 387 ln, what's V2? We know that our V2 was what? 0.75 divided by what? What's your V1? Your V1 was given to be what? 0.5 from your question. So you have V1 here to be what? 0.5. Are we together? So what you simply do is you punch this value with your calculator and you simply arrive at 41.67 kilojoules. This was my answer. I don't know what you get. So drop your answer too on the comment section if the answers here are very wrong. Are we together? Drop them on the comment section. Now, what are we seeing? We've already calculated for our non-flow work using what? Using the first formula that was given to us, which is the formula that has to do with volume, right? Now let's use the next formula that has to do with pressure, and let's see if we'll still arrive at the same value as what? 41.67. Are we together? Now using the next formula, which is RT ln P1 multiply P1 divided by what? P2. Let's see if we arrive at what? The same what? Value. Now without wasting time, we'll have that our RT, we know that that formula is talking about mRT, right? Ln P1 divided by what? P2. Let's impute the values and see if we arrive at the same answer. So if you impute the values, we'll simply have 1 multiplied by our result 0.287 multiplied by your T, it would be what 38.7, right? So we have this to be lane P1. What's your P1? Remember, our P1 was what 151.988. That was our P1 divided by P2 was given to be 101.325. So let's confirm those values. We're giving the value for P1 to be 151, right? And we're giving the value for P2 to be what 101. Are we together? Now you input those values there and you punch your calculator. Let's see if you arrive at what the same answer. So what you have will still arrive at the same answer to be what 41.66 kilojoules. So what we have here is 67. What we have here is 66. So maybe there should be a value that should be approximated to give you what 6.7. So you can see that they are still what the same what answer. Which of the in any of the formula you use, you still get what the same what answer. Let's go back to the next question. Let's go back to the next parameter we have to look for, and which is what our shaft work. Our what shaft work. So for us to calculate for our shaft work, what should come to our mind is we go back to our table, our given table, to see what our shaft work is, right? So now from our given table, we have that our shaft work, from our given table, we have that our shaft work, which is WSH, our shaft work still have the same formula with your what? Your non-flow work. So in essence, you go back to your question, you can tell the examiner that since you have your non-flow work to be the same value with your shaft work, you simply have your non-flow work will be equal to what? Your shaft work. This is telling the examiner that, oh, your shaft work still have the same what? Equation with your what? Your non-flow work. So without wasting time, you just took the value for your non-flow work. Since your non-flow work is what? 41.67 kilojoules. Your shaft work will also be what? 41. You simply have 41.67 kilojoules. So this is telling the examiner that your shaft work is still the same value with your what? Your non-flow work. So without further ado, we've already calculated for the work done of the system. Now let's consider the heat interaction, right? That was the next question that we were asked. That was the next question that was asked, to calculate for the heat interaction of the system. Are we together? Now I said for you to calculate for the heat interaction of the system, you need to know the heat interaction for state 1 and state 2, which is Q12. You need to know the change in internal energy, the change in enthalpy, and also what? The change in what? Entropy of the system. Now let's calculate for the Q12 of the system. Q12 of the system, what you do is you go back to your simplified table, you check the equation for Q12. And what's Q12? Q12 has the same equation with what? Your non-flow work. You can see that this is what? RT ln P1 over P2. This is RT ln what? P1 over what? P2. So since we have the same value with our shaft work and the same value with our non-flow work, you simply take the value for Q12, you simply tell your examiner that Q12 will be equal to what? WNF. And WNF is also equal to what? WSH. That's what you put down on your booklet. So this is telling the examiner that the same value you have for WNF will be the same value you have for your what? Your Q12. So your Q12 will actually be what? 41.67 kilojoules. Are we together? Now let's consider your change in U. What's your change in internal energy? Now from our given table, we have that our change in internal energy will be equal to what? 0. Our change in enthalpy will be equal to what? 0. Are we together? So you simply have that your change in internal energy here, since it is isothermal process, since it is what? Isothermal, So isothermal is telling you that for your change in internal energy, your change in internal energy will be equal to what? 0. Your change in enthalpy will also be equal to what? 0. Are we together? Now, what's the next thing we are to calculate for? The change in entropy of the system. Now, from what we have here, from our given table, from our simplified table, we have that for you to calculate for your change in entropy for isothermal process, you have an equation that says what? R ln what? P1 over what? P2. Are we together? This is it the same equation with this? No, it is not the same equation. Here we have temperature multiplying, but here we are not seeing what? Temperature multiplying. So if we use this formula, we are to calculate for the change in what? Entropy of the system. Now let's take the first formula, which is R ln what? P1 over what? P2. Now we'll simply have that our change in entropy will simply be what? R ln what? P1 over what? P2. Are we together? Now if you do that, remember we have mass. So if we are adding mass to what we have here, we simply have mR ln P1 over what? P2. And what's your mass? Your mass is given to be 1 multiplied by what's your R? 0.287 kilojoules per what? Kilogram multiplied by Kelvin. What we have here is what? Kilogram, right? Now this will be ln what? Ln P1, which is what? 151.988 divided by what's your P2? Your P2 is 101.325. So what do you do? This is also what? In Kelvin. So Kelvin, this is in what? Kilopascal, right? So since this is in kilopascal, kilopascal will cancel out kilopascal, yeah, and you are left with kilogram here. Your kilogram here will cancel out your kilogram. And if you punch this on your calculator, you simply have a certain value to be what? 0.1164 kilojoules per what? Kelvin. So this will be the value for your change in what? Entropy. Now what you do for me is go to your simplified table, pick the other equation for what? Entropy, which is what? R ln V1 over what? V2. Remember, you are multiplying this with mass, right? So you have M here multiplying R1 ln what? V1 over V2. And impute your values. After imputing your values, you punch your calculator and you drop the value on the comment section. Let's see if the same value we have here will be the same value we will have for our first what? Equation that we used. Thank you, everyone. Don't forget to like, comment, and share to your classmates. Thank you.